Hey, what is up, everybody? Hope you're having a fantastic day today. And today we are going to talk about measuring changes in thermodynamic properties for pure fluids or pure substances. I'm assuming you're going to know the first law, the second law, Maxwell relations, as well as constant pressure heat capacity. You should know this. And constant volume heat capacity. If you want me to derive, I maybe can make some other video sometime in the future. Alright, okay, so let's begin. What properties are we usually interested in finding? Usually we'll want to find enthalpy, internal energy, entropy changes, Helmholtz free energy, Gibbs free energy. These are usually, stuff we want to find for engineering calculations in general. So we know these two, Gibbs free energy and Helmholtz free energy, these are based on these three, right? So I guess for first step, you can start finding the enthalpy change, the internal energy change, and the entropy change. So these are what we're going to be focusing on first. Alright, so now you want to find this. How are you going to find the changes in these three things? We can start, you can start by using stuff we can actually measure. Something like temperature, pressure, volume, specific volume, or actually this is 1 over density. Yep. We can measure constant pressure heat capacity, constant volume heat capacity, right? So how are we going to get from here to here? Now that's going to be the topic of this video. So from as a start, we're going to consider the Gibbs free phase rule, which states that the degree of freedom is equals to the number of components minus the number of phases plus 2 for non-reacting systems. So for, let's say, one component system in one phase, that will give you 2 degrees of freedom. So for pure substances or pure fluids, there'll be usually 2 degrees of freedom. So specify any 2 intensive variables and you can find what you need. So let's say you want to find something like enthalpy changes. So how are you going to start? Well, we can start by considering this. You pick any 2 out of 3. Not 2 out of 3. 2 out of these 5 things you can measure. So we can usually measure T, P, and V quite easily. So as a first move, what you can pick is temperature, right? Because enthalpy change is an energy change, and obviously energy has to do something with temperature. So you always take temperature first. So what is the second thing you should specify? The pressure or the volume? So from the calculus side, we know the small change in H is equals to, I'm not going to say it out, but you should know what it's saying. Yeah. Alright, and this is using pressure, and this is using volume. Alright, so which of these two are you going to pick? Obviously you want to use one that is quite going to make your life easier, right? So we already know Cp equals to this. So probably we want to pick the first one for enthalpy. So dH equals to Cp dt plus whatever this is dP. Alright? So we can measure this by this adding to this. dP is okay, we know. We can measure it. This we can measure, this we can measure. But what is this? I gotta write this properly. What is this? Del H del P, keeping temperature constant. Oh. What are you gonna do? There are many equations you can use. Alright? So, to narrow down what kind of equations you want to use, you want to find out where these equations actually come from. So something like this comes from, the calculus concept. Or I just call it math. And obviously you don't want to be using this because this kind of complicates things. And it's also coming from math. We have this, which is the definition of enthalpy. And you can rewrite this in the differential form. As so. Or you can do it this way. So this is the definition. This comes from also the definition. This comes from first law plus definition. Definition of H. Yep. So, of these equations, what do you want to use? If you panic during exams, use the simplest ones. This one you probably don't want to use. This one you already used before. So you're stuck with these two. Right? And you want to get this, right? So let's make this equation look a bit more like this. So the first part we can actually consider is dividing everything by dP. So the first one goes like this. Oh yeah, dP. Actually, let's just keep the temperature constant as well. So let's shoot del. Alright, that's the first one, which is this. Sorry about the handwriting, but right. Plus V. This is just one. Alright. Now for this part, yeah, this is just one, right? Yeah. It's the same idea. Alright. So, of these equations, which should you use? This kind of, you don't know, you probably need a few more equations before you figure out what this is, right? But this is something you have seen before in the Maxwell relations before, right? So, from the Maxwell relations, we can write del S del Pt equals to minus del V del T P, right? So now I have this. All right. Now I can substitute this back into our enthalpy equation here, and voila. continue here. dH equals to Cp dt plus this lot. Alright, so that's just the enthalpy part. So at least in theory, you can measure any kind of changes in enthalpy by measuring, the density changes with respect to temperature and Cp. That's how you do it. That's one down. Alright, in the next video, probably going to talk about internal energy, U.